these things called unit vectors, which are vectors that have the length of one unit.
So let me guess. We're going to have a vector of a length 1 unit and call it a unit vector then.
That's exactly what I just said.
Oh.
And what these have to do with is basically if we have a unit vector, we can talk about the direction that vector is. Yeah.
We can make long vectors short and have a direction that's a unit long?
It's a direction
Okay.
vector.
All right.
So
I
we've
can
got
work with that.
this formula up here,
Okay.
which these last two things are saying the same thing. They're just simplified a little bit differently.
Okay.
I like
Let's
the
do
second
one.
way.
Well, let's work one out and we can see how all this goes together.
Okay, well, it's really tiny up there.
Yeah,
Here
it
we
is.
go. Here we go.
Okay, you're right.
Okay, so what we have to do is find the magnitude of this vector to start off with. So,
I know how to do that.
Yeah.
We did that a couple slides ago. You're going to square the first guy, square the second guy, and for Pete's sakes, make sure that the negatives are inside the parentheses.
Right, so that's 9 plus 4, which is 13, so square root of 13.
And leave it like that. Like, please don't decimal this out and get some decimal-y thing. Don't
do it.
This
is the magnitude of this vector they gave us. We want a unit vector that's in this direction. So if we drew it, -3, 2 would be this way. So we want it to be in this direction, but only with a length of 1, not square root of 13.
Right.
So to do that, we take
Square root
1
of 13 is almost a length of 4.
over square root of 13, and we multiply it into our vector, -3, 2.
We're not done here.
No,
though.
we gotta
we
move it
gotta
in.
actually use that as a scalar and multiply it in there.
Right, we're allowed to do that.
You gotta put it in there.
So that's -3 over square root of 13, comma 2 over square root of 13.
That's it right there. There's your unit vector in the direction of -3, 2.
Right.
And it's exactly 1 unit long. You could check that by
doing the Pythagorean
doing the
theorem
magnitude and
thing.
Pythagorean theorem.
You could check it if you wanted to. If you wanted to rationalize it, that's what it would look like.
The first one's okay for us, though.
Yeah, the first one's fine. So one thing that they do with these unit vectors is there's a different notation besides our component form with our arrow brackets that they like to use. Basically, they talk about 2 unit vectors. I is a unit vector that's going straight to the right, okay, and is 1 unit long. J, so this is I. J is a unit vector going straight up, and it's 1 unit long. These are the standard unit vectors, and what we can do is we can make any vector into what's called a linear combination of these 2 vectors.
Linear combination would be a line,
Yes.
linear line,
Yes.
and then we would use whatever numbers we were given for our vector as part of those components for that.
So an example of this is that 3i plus 4j is simply talking about the vector 3, 4. Any of the vectors we've used so far, we could instead write it like this.
So, okay, just make me smile and write our unit vector there for negative square root of 3.
This
Oh,
one?
look, there's a
This
smile.
one?
Yeah.
Okay.
What's that one in IJ?
Well, let's see here. We would drop the arrow brackets and we
Right.
would write -3 over the square root of 13 I plus 2 over the square root of 13 j.
There you go, standard unit vector right there.
I and j are the unit vectors. These are vectors technically, although we don't necessarily normally write the vector symbol over them.
Right.
Okay.
But they're
these
bold.
these
They're
are
in bold,
vectors.
which means vector.
Right. And so whenever we're doing stuff with these, this is not I like the imaginary number.
No,
It's really
no.
inconvenient that it's the same letter.
Except there's this is a vector.
This is a vector.
And if you look in your book, those eyes are not usually bold.
Yeah. Wait.
I'm pretty sure. I
don't think they bold the eyes.
Let's just double check.
I don't think they bold the eyes in this section at all.
Okay, let me just real quick.
But really, here's my point. If you want to make this easy on yourself, every time that you see something written like this, 3i plus 4j, immediately write it in component form, and then you don't have to deal with it. If it asks you to have your answer as a linear combination of i's and j's, well, you switch it back to a linear combination of i's and j's by putting an I with your x, a j with your y, and adding them together.
Hold on, I've almost got it.
You're nowhere near.
Look,
6.1.
No, but I was going to look up the complex numbers page 53.
That's not what I'm concerned about.
No, but look at this, because I'm pretty sure.
No, you're absolutely right. They don't bold.
Look,
They
that's
don't
not a
bold
bold.
those eyes, but I don't think
What do
they
you-
bold the other eyes either.
What? Yes, they do.
Let me just hold your horses. Hold them. Oh, they do. They
Okay,
do.
see?
They do bold them. They
So,
do bold the eyes in
there
Jason's
you go.
section.
Who was right?